Okay, so 8.2, as I mentioned before, is adding and subtracting rational expressions. And, 8.1 is a little easier because multiplying and dividing is straight up, right? You just factor and cancel. With adding and subtracting fractions, you have to get a common denominator. And so that's what makes this section harder, because finding a common denominator with rational expressions can be tough. And I'm going to walk you through it. There's going to be a bunch of notes in terms of sort of directions on what you're going to do, and some of it won't make sense as it stands on its own. But as we get into each problem, it'll make a little more sense as we go through it. So I want to provide you that recipe, those directions that you can follow when you get to a point where you feel like maybe you're stuck. So again, first thing, whenever you add or subtract fractions, you have to have a common denominator. You don't for multiplying and dividing, so that one's kind of nice. But for adding and subtracting, you have to have a common denominator. And the bulk of this process, figuring out what a sum or a difference of rational expressions is, comes down to doing finding the least common denominator correctly. Okay, so that's the first part. So there's two parts within that, and this is what we talked about, those videos that we watched back at the beginning of 8.1. You have your loners, you have your groups, and how you find a common denominator with loners is different than how you find a common denominator with groups. We treat them separately, we treat them differently, and we do them differently. And so I'm going to give you directions for what to do with the loners. I'm going to give you directions for what to do with the groups. And oftentimes in your problems, you're going to have just loners. Sometimes you're going to have just groups, or sometimes you're going to have a combination of both. So it's important to kind of keep that straight. In all of these problems, what's critical is that your denominators, just your denominators, are completely factored. You don't have to worry about factoring the top, because most of the time you're going to multiply that back out anyway. Because if you think about just regular fractions, when you get a common denominator, when you change the bottom, you also change the top. And so by factoring it out, the numerator that is, you're going to end up multiplying it back together anyway. So you only need to worry about the denominator. Make sure it's completely factored. All of them, for that matter. All the denominators are completely factored. Okay? So for monomials, for loners only, here's what you're going to do. For the coefficients, the numbers in front, you do it just like you did a regular fraction that had no variables in it. Okay? Find the smallest number that all the denominators go into. Just your regular lowest common denominator of the numbers. And how you do that, I'm going to leave up to you. If you want to use prime factorization, if you want to make a list, if you just want to look at it and be like, oh yeah, or see if the smaller number goes into the biggest number, that kind of thing. But that's what this is what least common denominator is. It's the smallest number that all the numbers go into. Okay, so that's just for the coefficients. The variable parts are easier. The variable parts, you just use the highest power on the variable. Now, here's what's important. If one term doesn't have a variable and the other one does, then the highest power is the one that exists. And that's how you come up with your least common denominator for a loner, for a monomial. Now, we'll get to what we do after that here in a minute. Okay? But our priority right now is just to find the common denominator. Like I said, sometimes there aren't going to be loners, there aren't going to be monomials. And sometimes there are only going to be monomials, and sometimes there's going to be a combination of both. All right. Good to move on? Not yet. So, once you do find the common denominator, this is the part that I think seems kind of confusing by itself. But when we put it into action, it'll make more sense. Okay. You have to multiply each numerator and denominator by whatever's missing from the common denominator. Or from the current denominator to equal the common denominator. Let me say that again. You have to multiply top and bottom by whatever's missing from the current denominator to make it turn into the common denominator. Again, we're going to go through a whole bunch of examples, and this will make a little more sense to you when we do the example. But I guess what I'm trying to say here is that, you know, when you decide what the common denominator is, you have to look at the current denominator and be like, all right, what do I have to multiply that thing by to turn it into the common denominator? That, to me, that's what I'm considering the missing part. So then when you figure out what you have to multiply that denominator by to get it to turn into the common denominator, you got to multiply the top and the bottom by that. And you got to do that for all of the fractions. That's what I'm trying to say. Okay? And this is true whether I have loners or groups. This is still true. Okay? So let's talk about once you have that common denominator, done the multiplying, then you can add and subtract the tops. So that's what, you know, adding and subtracting fractions is. Get that common denominator, and once you have that, and then you've done your multiplying with the top and the bottom, then you copy the bottom and add the top, or subtract the top, whatever. Okay? And of all the things related to fractions that you guys struggle with, it's this. Because there's a lot of rules. You know, for multiplying and dividing, it's just like factor, reduce. Keep, change, flip. That's it. But for this, it's like, okay, I got to get a common denominator. Then I got to do some multiplying. Then I got to copy the denominator. Remember that. I don't add those, but I add the tops. So there's a bunch more rules here. And this is where some of you with fractions started to feel frustrated. It was when we got to this. And on top of that, we're going to add a bunch of variables into it and factoring, and so it can be kind of stressful. So yeah, it's a couple levels of difficulty higher than multiplying and dividing. Anything so far? We'll talk about what to do with the groups. The groups are a little bit easier, to be honest, than the loners. And we'll talk about how to work with those. All right, so we'll just jump into an example. We've got 3 over 10x squared plus 7 over 15x. Okay? That's nice. So, in this case, both of my denominators are loners. I don't have any groups. So you have to look at these things separately. And the first place I want to look, let's go here, are my coefficients. All right. So I just treat 10 and 15 like I would any other set of numbers in a normal fraction. I got to figure out, first, does 10 go into 15 evenly? No. So I know 15 can't be the lowest common multiple, so I got to go bigger than that. So what number does both 10 and 15 go into? 30, okay? So I know that my common denominator is going to have something over 30 in both cases. All right? Now, for the variable part, I just look at the x squared and an x, and I take the one that's bigger. So which one's bigger? X squared, okay? So it's my common denominator is 30x squared. Now here's where I get into that multiply top and bottom by what's missing. Okay. So in order to get from 10x squared to 30x, what factor is missing from 10x squared? What do I have to multiply this by? 3. So the factor of 3 is missing. So I multiply the top and bottom. Do you know why I multiply the top and bottom? Because what?
Because whatever happens to the bottom has to happen.
But why? Why does that happen? Why do we do that? Doesn't change how do you know it doesn't change? You're very warm. You're right around it. You're right. The value of this fraction, 3 over 10x squared, is not going to change. But why? I multiplied it by 3, and then I multiplied it by 3. That's obviously changing, right?
Because you're multiplying the fraction by the same number as a whole. So, like, this doesn't change.
So warm. You're so warm.
So reduce it by 3 afterwards.
Correct, but why?
Because those are the rules.
Shane, what? Say it, please.
3 over 3 is 1.
Thank you. 3 over 3 is 1. So, Grace, you were right on it. You were right on it. The value's not going to change because I'm just multiplying by 1. That's why we multiplied by the top and the bottom by the same thing, so that we're multiplying the fraction by 1. We're just going to change what it looks like. Like we're going to give it a haircut. Still the same person. Okay? Now, what's missing from this? What's missing from 15x in order to turn into 30x squared? 2x. So I have to multiply top and bottom by 2x, because 2x over 2x is just 1. So what's the top now? 14x. Okay? Questions so far? So that's when I was talking about the thing that's missing, that's what I was talking about. All right, so my final answer. Copy the denominator. Combine the tops. So I have 9 plus 14x. What's that? Very good. 9 plus 14x. I can't combine them. That's my answer. Okay. Now, you are able to look at the 10 and 15 and figure out it was 30 pretty easily. Okay. Sometimes these numbers aren't going to be as nice. And so you might go back to your old school days of making the list. You remember making the list 10, 20, 30, 40, 15, 30, 45, 60. You remember doing that? And then you found the one where it became the same. You can do that. You can use prime factorization and break it down that way. When you make a factor tree. Okay, yeah.
Are we ever going to have decimals and fractions in the denominator?
Yes and no. Yes, but you get rid of them. Okay, but we won't see too much of that. Okay, we'll get into some more complex fractions here in a minute. Last example. All right. Other questions before we move on to the next example? Okay. Here's another one. I want you to try this one first. Okay, you've got 3a squared. Let's see if I can make it bigger. 3a squared over 16b squared minus 8x over 5a cubed b. So again, same situation. I've got loaners as denominators. So try to work through that and let's see what you get. Let me give you a little hint with respect to the numbers, 16 and 5. Think of the factors of 5. Think of the factors of 16. Besides 1, do they have any factors in common? Right, because this is 2 and 8, 4 and 4. This is 1 and 5. When they have no factors in common, that's the time you absolutely 100% know that the way that you're going to find the numerical part, you're going to have to multiply them together. If they have a common factor, even could be as small as 2, multiplying the two numbers is not necessary. It's 100% necessary here because 16 and 5 have no common factors, which means the numerical part is going to be what? Of the common denominator. What's 16 times 5? 80. Okay. Another way to think about the common denominator when it comes to the numbers or the variables for that matter is whatever your denominator is, your common denominator must contain everything. It must be representative. So there must be a 16 inside of the number. There must be a b squared inside of your denominator. There must be a 5 inside of your denominator. There must be an a cubed inside of the denominator. Well, there must be a b. Well, the b's already in the b squared, so it's represented. You just got to make sure that all denominators are properly represented in your common denominator. Are they contained within it? And if they are, then you're good. But like Andrew and I were just talking, he came up with a bunch of different denominators for the variables. One time he had just the b squareds. Well, the a's weren't represented. Then one time he had the a cubes. Well, now the b's weren't represented. So they all have to be represented. They got to all be in there. Everybody gets invited to the party. Okay? Yes, if that's possible. Okay. So we've already talked about the numerical part. And actually, I'm going to show you another little trick. Once you find your common denominator, okay, you can actually write the whole thing as just one fraction instead of writing two separate ones. I'll show you how to do it. All right. So when I look at the a's, I said use the highest power. And there's no a over here. So the highest power is a to the third. And the highest power at the b is b to the second. So here's what I mean by everybody's invited to the party. Okay, 16 is a factor of 80. 5 is a factor of 80. Both numbers are represented by this 80. A to the third, well, there's no a to the third here, so there's no a to be represented, but this a to the third is there. And the b squared, this b is included in b squared, and this b squared is included in b squared. So this common denominator covers everything. And that's the key to finding the common denominator. Make sure all the denominators are equally represented somehow. All right? Then it's just a matter of going, okay, what's missing? What do I need to multiply by? So what times 16 gives me 80? 5. So I know that's going to be 5. And the b squared's good, and I'm missing the a to the third. So I'm missing a 5, and I'm missing an a to the third. Nothing is missing with the b's. And then I just have to do that again on top and multiply that. So that gives me 15 a to the fifth. Okay. I'm going to have a minus here from this minus. So what's missing from this? 5 times what gives me 80? 16. Okay. Anything missing from the a cubed? Well, the a cubed, it's all contained there, but I'm missing one b here. So I have to take that, I know that's 16. There we go. 16 times b. Because 16b times 15a to the third will give me this. This is the factor missing from this to get me here. And then I have to do it to the top. So I get 48 for 128b. Now Mandy asks, can you simplify after you've done this?
But what about the x?
Oh, I lost the x. Sorry.
I mean, like the variable.
Yeah, I mean, if I could, sure. What could I cancel? Where could I cancel?
I mean, if there's an a to the third and an a to the fifth.
But since there's no a over here, okay, and we've been working on simplifying these kinds of things before, it has to be in both places. If it was, here's what I will tell you when we do this. If it is, then your common denominator is not the lowest common denominator. It's just a common denominator. Because if there were a's over here still, and an a with this a and this a, that means this is too big. Didn't have to be that big. That's how that will happen most of the time. At this point, the only way to do any canceling here, because remember, this is a group on top. And I have a loner on the bottom. You can't take part of a group and cancel it with a loner. It either has to be a whole group or there has to be a loner that could be factored out. So this is my final answer. Raise your hand if you had it. Oh, good. 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 Questions on it? Okay, so you got to watch your steps. Right? What's missing? Now, you could have written this as 15a to the fifth over 80a to the third b squared minus 128bx over 80a to the third b squared. You would still need to get it to this point and combine it together as one fraction. Okay? But hopefully you like skipping that step a little bit because it gets us to the same place. All right, let's make this a little tougher. Like this. Now, these are going to be more common problems that you're going to see. Things like this. And as you continue to move through higher level math, you will see more of this than you will of the monomial stuff. Okay? In fact, actually you'll see a little of both where they're combined together. Okay? Now, as I mentioned earlier, and as we did in multiplying and dividing, the first thing I need to do with the denominators is what? Not yet. Factor. I got to factor first. Factor first. So go ahead and factor those denominators. All right, so this first one, I'm going to leave the x minus 1 alone. It's fine. How do I factor the bottom here? X minus 3, x plus 2. How do I factor the second one? 5 times the quantity, x plus 2. Okay? Now, once it's all factored out, I have to look at my loners. I have to look at my groups. In this case, there's only one loner, which means it needs to be a part of the denominator. So my common denominator is going to have a 5. That covers this. Okay? Now the loner's taken care of. I don't have to worry about it anymore. Okay? Now, for my groups, I need to make sure that everybody is represented. And at most what do you notice about the denominators here? What's something you notice? I'm sorry?
There's an x plus 2 and another.
Yeah, there's an x plus 2 and an x plus... They have an x plus 2 in common. Okay, at most, how many x plus 2s does one denominator have? 1. There's only 1. Okay, so there's 1 here, there's 1 here, which means I only need 1 in the common denominator. Because at most, there's 1. So all I need is 1. So I have to have an x plus 2 in my denominator, and that covers this, and it also covers this. What else is not represented? X minus 3. So that needs to be represented too. Now they're all there. Okay? And a quick little check before I move on and do my multiplying. Is this denominator completely represented in my common denominator? Yep. Is this denominator completely represented in my common denominator? You bet. Which means we're good. I found my lowest common denominator. Now I've got to do my multiplying. So from this current denominator, I'm going to start using the lingo that I used at the beginning, which didn't make sense sitting on its own. What is missing from the current denominator that the common denominator has? A 5. So all I've got to do is multiply top and bottom by 5. Okay. So what does that give me on the top? 5x minus 5. I'm distributing. Okay. What is missing from this current denominator that the common denominator has? X minus 3. So I multiply by x minus 3 and x minus 3. Be careful. Consider this minus 4. Okay? Consider this negative 4. Because what you want to do is distribute it like a negative 4. And that'll make life easier. So when I distribute that negative 4, I get negative 4x plus 12. Okay. I wish there was, actually, maybe there is. Let's see if I can do this. See, I really want to think of it like that. And that way I'll get my sign straight. Now, from here, I can simplify on the top. So what do I get when I simplify on the top? Plus 7. Now sometimes when you get to this point, like if this was an x plus 2, then you could cancel them. I mean, it's not. But if this would have been an x plus 2, you could cancel them. If this was an x minus 3, you could cancel them.
That doesn't mean that it wasn't big
No,
enough.
this can kind of happen with these kinds of problems. That can happen. That doesn't mean you did anything wrong. That can happen though. So this is my answer. Question?
So if you did cancel, you just put a 1 as.
Correct. If you did end up canceling the entire top or the entire bottom, that's just equal to 1 in that particular spot. Okay? All right. Questions? Other questions? I think I have one more problem to do. I do. One more problem to do. But this is basically the gist of it. Okay? Does that concept of the missing part of the denominator, does that make sense now? What I was trying to allude to? Okay. And that's why I want you to have those sets of directions so that when you get to those problems and you maybe get lost, you can help find your way. All right, the last part I want to talk about are complex fractions. Okay? And complex fractions are just fractions within fractions. And this is, Declan, what you were talking about a little bit earlier. All right, and I'm going to show you one way to do these. There's actually a couple different ways to do these, but I'm going to show you one that keeps it aligned with what we just did, rather than teaching you something new. All right, we can keep using the same things, but for the most part, these problems are going to look tougher. They're going to seem harder. In fact, on your 8-1 day 2 homework, you had a couple problems that sort of look like these already. Or at least similar, okay? And they're problems that are going to look like this. So I'm going to have fractions within fractions. All right, so on top, in my numerator, there will be fractions. On bottom, there will be fractions. And we'll also include addition and subtraction. So the difference between the other problems, they were straight up addition and subtraction problems. In these, what we're going to do is combine addition and subtraction with division. That's what makes these complex fractions, because of this division right here. So essentially what we're going to be doing is you're going to have to add, subtract, and also divide, which means we're actually going to have to add, subtract, and multiply. So we're going to combine what we just did with the beginning of 8.2 with what you did in 8.1. All right, so the first move here is to turn this into sort of a separate division problem, like this. Okay. And so what ends up happening is I have an addition or subtraction problem, an addition or subtraction problem, and then I'm going to have to use my division. Right?
Good.
Now, this particular problem is not that challenging in terms of the addition and subtraction getting the common denominators, but some of them are going to be a little more challenging than this, but not out of your scope of possibility. All right, so over here, if I focus on this 1, what's my common denominator going to be out of this expression here? X. So what is 1 going to be if the denominator is x?
1 over.
I have to have x over x, right? I got to have something equal to 1, so that's going to be x over x. What's my common denominator going to be over here? xy. So what's missing from this?
Okay.
What's missing from this? Y. Okay. So that's where we're going to go. Now, I didn't really write it out. We talked about this being x over x. I have to multiply this by x, multiply this by y, and that's where this comes from. Okay. Now here, when I bring them together, what do I get? What goes on top? X minus y over x. What about over here? X plus y over xy. Okay? So here's where I'm at now. I did my adding and subtracting. That's done. Okay? Now, what do? Keep change, flip. Okay. Finish it. Can anything cancel? One of those. What can cancel? Which X?
Yeah, one from the X and one from the XY.
X and the XY, you bet. I can cancel this X, it's a loner. With that X, it's a loner. Can I cancel anything else?
There we go.
So the -1 thing that I talked to you about only works if, so this X minus Y, this would have to be a Y minus X. So if I tried to take a -1 out of this, it would be -X plus Y. So their signs would still be off. Can I cancel these Y's?
No.
Loner, group. That's it. That's all you can do. We're done. Question?
What about the X from the X plus Y, the X minus Y?
Again, you have to either do the whole group, can't do part of a group. It's the whole group or nothing. Again, as I mentioned before, the only way I could do canceling with groups that sort of look different is if they look like this, where it's subtraction and the order is off and you can cancel those as a -1. I don't have that here, so this doesn't apply, but that's the only way you can do something like that. Okay, so that's it. So the complex fractions that you're going to see, I want you to make them more simple. One, by separating them out, like I did. We did that first. We separated them out into the division problem that it is. Then do the addition of this one, or subtraction, or the addition or subtraction of this one, and then eventually you're going to keep, change, flip, and bring them together. So these complex fractions are complex, because not only do you have to add, you got to do it twice. Not only do you have to divide, but you have to keep, change, so it combines everything. And so that's why those problems at the end of the assignment bring everything together for you, okay? And I will tell you on your quiz on Friday, 8.1 and 8.2, this basically covers 8.1 and 8.2. 8.3 is a whole separate animal. Graphing reciprocal functions is totally separate from this. So if you get good at this part, you're going to do fairly well on the quiz on Friday, okay?